So we kind of already talked about naming the prisms when we looked at the nets, but a prism, by definition, is a polyhedron. It's no longer called just a polygon, because that would be two-dimensional. A polyhedron is three-dimensional figure that has exactly two congruent parallel faces that are called the bases. What is four-dimensional? Don't know. Don't know that exists. But if you want, three-dimensional is what we are, living in the world. So what would be four-dimensional?
I don't know. I'm asking you.
There isn't a four-dimensional. The other faces are called lateral faces. So the bases are whatever you have two of. Okay? They are not always the top and the bottom because the shape can be flipped on its side. So just be aware of that. The lateral faces are always going to be rectangles in a prism. Okay, think of those as like the sides. Again, sometimes it's flipped over, but. And a prism is named based on the shape of its base. So if the base is a hexagon, it would be a hexagonal prism. If the base is a square, it could be a square prism or a triangular prism. The altitude of a prism is the perpendicular segment that joins the planes of the bases. So another word for altitude is the height of the prism, which is the length of that altitude. So again, the altitude of this one or the height of this one would be this segment from here to here. Now when they flip the prism on its side, the height would actually be from here to here because the prism has been flipped sideways. And then this is a cylinder, we'll talk about that also today, and that would be our height. Prism can be classified as right or oblique. So in a right prism, which is what we normally will see most of the time, the lateral faces are rectangles, and the lateral edge will be perpendicular to the base. Now an oblique prism looks like it's tilted, like slanted. The big difference is that the lateral faces will no longer be rectangles, they will be parallelograms. So to find the height of the prism, they'll usually give it to you, but it'll be a little dashed line outside. Instead of being a side of the prism, because that's slanted, that's not height. It'll be a perpendicular, imaginary dotted line. Who can name, and I should tell you, we don't have markings on all of these like I normally do to tell you that it has to have 4 markings or 4 numbers. So you will use your eye to judge the shape. What type of prism do you think number 1 is by judging with your eye?
Cube.
No, it's definitely not a cube. This is not the same size as this. So a cube has to have all 6 sides being the exact same. It could be a rectangular prism, but the base to me looks like a square. So it'd be a square prism. I would accept rectangular prism if you wrote it though, because you don't necessarily know it's a square. But again, it's named based on the base. So the base is whatever you have 2 of. Now, if the sides also appeared to be squares, then it would be a cube. Next one, our bases again are what we have 2 of. And they will be parallel. So what do you think we would call this prism? A trapezoidal prism. If you were to write just trapezoid prism, I would accept it. And how about the last one? A pentagonal prism. Pentagonal prism. Sure. No. Pentagon prism. Yes. Penta is just making appearance stuff. Just like 40. All right, we have cylinders also, which are easier because you don't have to name them based on their base because their base is a circle. So really, cylinders are circular prisms, but instead of calling them that, we call them cylinders. And cylinders are super easy because there's only 2 dimensions. There's a radius and a height. So you don't have to do as much work. And that's because both bases are circles. You can still have right cylinders, which means that the height is going to be perpendicular to base, or an oblique, which kind of looks like the Leaning Tower of Pisa, like slanted. The only thing you have to worry about is that the height will be this little dashed line instead of using the side of the cylinder.
So
The height just becomes like a dashed line instead of...
on the side.
Yes.
Okay.
Yes, because it's the distance from circle to circle, from base to base. All right, so we have two types of area today. We have lateral area and surface area. Now remember, I said lateral faces are the sides. So the easiest way to think of lateral are like the four walls in the room. Okay, so lateral area will be the total area of those four walls or those sides that you have. So that will be all of the faces except the bases. So it won't include the top and the bottom or whatever the shape of your base is. Surface area is the area of all the surfaces, which would include the bases, or in our room, the ceiling and the floor. So lateral area would be kind of useful if you were painting a room. Let's assume it didn't have windows. You would be painting all the four walls. That would be lateral area. If for some reason you wanted to paint the ceiling and the floor, that would be surface area. That would be all the surfaces. And so as I'm going to show you a bunch of formulas below, if you don't like them, you are welcome to just think about all of the surfaces, find the area of each one, and add them together. So in this one, you would have a bunch of squares. Find the area of one square, and then you just have to multiply by 6. Now this lateral area and surface area of a cylinder are a little bit different. Okay, lateral area would be, if you think of a toilet paper roll, like the distance around the sides. If you unroll that, it actually makes a rectangle. The height of the prism, or the cylinder, would be h. The length of this rectangle is the circumference.
Excuse interruption. Ethan, Bond, please report to the office.
If you wanted to find surface area, you just add on 2 circles at the end.
Please report to the office.
All right, so some formulas for lateral area of a prism. Again, if you don't like these formulas, you could just find the area of the rectangles and add them together. But formula for lateral area is little p times capital H. And while we're here, let's talk about what those letters stand for. P is the perimeter of the base. Kind of like I just showed in the cylinder, which was the perimeter of the circle. Okay, H, capital H, is the height of the prism. We don't use lowercase h because that usually is like the height of the triangle. So capital H will be the height of the prism, showing you that it's from base to base. And while we're here, big B is going to stand for the area of the base. So the bases are super important. You have to find the perimeter of that base shape and the area of that base shape. Now for surface area, there are 2 formulas. The first one is useful if you are asked to find both of them. You just take what you got for lateral area and you plug it in, and then you add 2 bases. In case they just ask you for surface area, though, you can use this formula. All I've done there is taken a lateral area formula and substituted it in. So again, you're going to have to do a lot of work. You're going to have to find the perimeter of the base, adding up all your sides. You're going to have to find the area of the base. So let's go ahead and just jot down for big B. You're going to have to know all the formulas from last chapter. Those won't be on your formula sheet. So if the base is a triangle, you'll use 1/2 base height. If the base is a rectangle, you'll use length times width. If the base is a polygon, which is draw like a pentagon or something, 1/2 ANS. If the base were a trapezoid, 1/2 HB1 plus B2. So you still need to know all your area formulas because you will have to use those depending on what shape the base is to find the area of the base. Okay? So there's not one formula for big B. There are a bunch of formulas. Did I miss any? I mean, square is S squared, but you can just use length times width for that. I think those are all the ones we learned. All right, now cylinders. Again, these are easier because the bases are always circles. So it's always going to be 2 pi r and pi r squared for our circumference. So the lateral area will be 2 pi r times the height. And the surface area, there are 2 of them. Lateral area plus 2 circles, so plus 2 pi r squared. And surface area, which is 2 pi r, and this should be a capital H, plus 2 pi r squared. Only reason I give you both is that, again, if you're asked to find the 2 things, you'll find the first answer, plug that answer in, and then add 2 circles. If you're just asked for surface area, I would just use the second one.
Lateral area of the cylinder is just the circumference.
Times the height.
D.
D pi times H if you wanted to abbreviate that, yes. All right, so let's take a look. We have, I think, 4 examples today. The biggest mistake is that when you guys see a shape and I ask you what B is, you'll tell me 4. Like, you'll just look at the base and just like write down the number that is on the base. So you have to remember that big B stands for the area of the base. Some of you will benefit from shading the bases because that'll remind you. Those are the 2 things that we're looking and focusing on. That will remind you also to find the perimeter of that shape and the area of that shape. So go ahead and jot down the formulas. Lateral area is P times H. Surface area is lateral area plus 2B. Now what I like to do is I like to just jot down what everything stands for over here and then plug into my formula. First of all, what shape is this? No, 4 and 3. A rectangular prism. Okay. Since we have numbers, we can classify that. All right, so we need to find out what P is. Remember, P is the perimeter of the base. So this is one of our bases. We find the perimeter. 4 plus 3 plus 4 plus 3 will be 7 plus 7, which is 14. Make sure that you don't just add the 2 they give you. You know that in a rectangle that the opposite sides are congruent. So you're finding the perimeter of the base. Capital H is the height of the prism. No work required, just look at it. What is the height of the prism? Distance from base to base. 5. The height is distance from base to base. That's just 5. Now for big B, remember that this is the area of the base. So in this case, the base is a rectangle. So I'm going to be using length times width, which is 3 times 4, which is 12. So if you do all that work off to the side, all you have to do then is sub in your formula. If you don't do that work, a lot of you will make the mistake of just plugging 4 in for B, or just coming up with numbers in your head for P. So if you put in the work over there, the rest of it's just plugging in and evaluating. So go ahead and plug those into your formula and see if you can find lateral area and surface area, and pay attention to your units, since this is still area. Should be getting 70 square centimeters for a lateral area, 14 times 5, and we should be getting 94. Big thing to note, surface area always has to be bigger than lateral area because you're adding a top and a bottom, a base and a base. Okay, make sure you do follow order of operations here and multiply before you add, so you don't get 72 times 12. All right, our next one. What shape is this? A what? A triangular prism. Which means the bases are triangles. So again, it may benefit you to highlight them. This time the prism has been knocked over on its side, right? So the base is no longer the bottom and the top. The base is now the front and the back. So we're going to find the perimeter of a triangle, which is our base. We're going to find the height. And we're going to find big B, which is the area of the triangle, which is the base. So what would the perimeter of one of my triangles be? 12 is correct. Where are you getting 17?
I had 10.
One of the sides is 3. The other side we don't know, but if you look backwards, it's a 4. The third side you do not know. You'd have to figure out using a triple or Pythagorean theorem. This would be a 3, 4, 5. 7 plus 5 is 12. Now, a lot of you will find the perimeter of the rectangle. because whenever you hear base, you think bottom, which is not the case. The base is whatever you have two of. So that's why I say if you shade them, it will remind you to find those shapes, not the bottom of the figure. All right, the height. What is the height of our prism? 6. Remember, that's the distance from base to base. So imagine this being like picked back up again so that the triangles were on the top of it. Now, big B is the area of one base, which is the area of the triangle, which will be 1/2 base height. Again, the formula for this will change with every single problem. Now, the base and height have to be perpendicular. Lucky for us, this is a right triangle, so it's just 1/2. It doesn't matter if you put 4 for base and 3 for height or vice versa. 1/2 of 12 will get me 6. Once you have all of that work done, then we just plug into our formulas. Now again, let's suppose you're like, Mrs. Bennett, kind of losing me with all this stuff. If you prefer, you can find the area of the triangle, double it, find the area of each of the rectangles, and add them all together. So if you don't like these formulas, you can just find all your areas and add everything together. And that would work just the same. But plugging all this stuff in, we'll get lateral area is 72 square centimeters. Take that and plug it in for lateral area over here. And our base was 6, big B. And our surface area is 84 square centimeters. All right, cylinders are everyone's favorites because you don't have to do all that side work. There's only 2 dimensions in a cylinder, a radius and a height, and those are the only things in the formula too. So you basically just plug in and multiply a bunch of stuff together. So first of all, jot down your formulas. Lateral area is 2 pi RH. Surface area is lateral area plus 2 circles, 2 pi r squared. And then literally, you just plug in. The radius is given. Sometimes you have to divide by 2 to get the radius. Okay, that's like as hard as they get. The height is set. And then you just plug into your formulas.
The shape has two shapes in it that are also like the same on the next one.
And so we should get 42 pi for this one. Again, square inches. A couple of you on your quiz just put pi as like you thought it was a unit. So make sure that you include units after that. So 2 times pi times the radius times the height. Plug this in for LA, our lateral area. And then we'll add 2 times pi times 3 squared. And then make sure you do your order of operations. 3 squared is an exponent that gets done first, which is 9. Then we do our multiplication. And then lastly, since these both have pi's, we can add them together. 42 plus 18 will get us 60 pi square inches. So cylinders, again, are going to be your friends because kind of just plug in. Saving the best one for last, we have another prism. What shape is this? A hexagonal or a hexagonal prism. Okay, so again, it's the 2 faces, and then everything else is rectangles or rectangles. So this is when we're going to have to do some work. We have to find the perimeter of the base. Remember, the base is a hexagon. It's the front and the back of the shape. So we have to find the perimeter of the hexagon. You know my hexagons turn out really well. What would the perimeter of the hexagon be? One side is 6.
36.
And we have 6 of them, 36. You'll remember we had a formula which was n times s, but I think most of you can figure out without using a formula. So you have one side that's 6 and you have 6 of them. All right, what is the height of the prism? What is the distance from base to base? 12. Okay, again, it's the sideways height because they flipped it over. Height is 12. Now, big B is where it gets real. What's the formula for the area of a polygon? 1/2 ANS or 1/2 AP. You could use AP because we just found P, but it doesn't matter. Problem is you don't know the apothem. And again, a bunch of you will do very poorly on the chapter test because whenever I give you the formula that has the B in it, like you get the formulas. Some of you will just plug in 6 because 6 is on the bottom. Big B is the area of the bottom, the area of the base. So just don't think you can plug numbers in. It's not that simple. Big B is the hardest part of the whole problem. Now, we need to find the apothem. Remember, the apothem goes from the center down to the base. So we have to do what we did before where we draw in our triangles. We have to find our angles. So we'll do 360 divided by n divided by 2. So 360 divided by 660 divided by 2 will tell me that these are each 30. I'm actually going to redraw one of them down here so that those of you in the back can see what is going on. Now we do know the whole base was 6, which means that half of it is 3. And you could use at this point SOHCAHTOA or special right triangles. I'm going to do special right triangles, but you could do sine, cosine, or tangent to find your apothem. So across from my 30 is my S, across from my 60, S root 3, and across from the 90, 2S, which you don't need that one, but why not put it there? So we see that S is 3. So the height of this triangle has to be 3 root 3, which that would then be our apothem. So we'll have 1/2 times the apothem, 3 root 3, times the number of sides, which is 6, times a side length, which also happens to be 6. And then you can multiply all the outside numbers together, and you should get 54 root 3. Where does popular stand? Christopher? All right, so that's big B. Now you just have to plug all this stuff in. Find out your areas. So for lateral area, we'll get 36 times 12, which will get us 432. Take that and plug it in for lateral area and add on 2 bases. Now, if the directions were to ask you to leave it in simplest radical form, you would just go ahead and multiply those together to get 108. You would not make it the square root of 6, though. It would just say the square root of 3. So that would be your answer if it ever said in simplest radical form. They don't have directions on this one, so we'll do both. We could also type this into our calculator to get a decimal approximation, which should be 619.1, and these would both be square meters. Tomorrow we're going to look at the pyramids. The pyramids will be different formulas, obviously. You're still going to have to find big B because you'll have one base in a pyramid and all the sides will be triangles. Okay. The closure asks us